Alright, this lesson is on functions. So we're going to talk about just different things about functions, things that you should have been a lot of exposed to in your previous classes, but we're just going to review. So to be a function from set A to set B, it has to be a relation that assigns every element x in set A to exactly one element y in set B. So the key is really focusing in on the x's. Every x has to go to only one y. So every x goes to one y. That's what it means to be a function. So I have a little song for you. It goes to a classic Italian song. If the moon hits your eye like a big pizza pie, it's amore. So that's what this little song here is. I'm going to sing it for you. If the x that you try goes to only one y, that's a function. So if you look at the examples, all of these x values here are only going to one place. So that's why that one's a function. But if you look at the next example, these first x values are fine. It's this last x value. It's going to two different y values. This is why this is not a function. This one's going to two y values. It can only go to one y value. Then we just have a couple terms to refresh here. The domain is the set of all x values, and the range is the set of all y values. Really easy way to remember it is it's alphabetical. Domain becomes before range, so x comes before y. So domain is x, range is y. Here's a couple of examples of looking at different things to determine if they're functions. This first one, we're looking at a list. So your focus is, again, it's the x's. Does every x go to only one y? So you want to focus on the x's and see if there's any that would go to two different spots. So if you look at that closely, it's this guy's right here. This -1 is going to 4 and to 5. So this is not a function, because that -1 value goes to two different y values. If you look at the next one, if we look at each of these values in the x, they're not used more than once, so they're each already going to only one spot, so this one is a function. Do note that the 9 and the y gets used more than once, but we're not focused on the y, we're just focused on the x. You might also see some in words that you have to decide if it's a function. My suggestion would be to make a table of potential values. So this is talking about x being the number of representatives from a state and y being the number of senators. So you need to know a little bit about how they pick representatives and senators, how many we have in each state. The representatives vary, it's based on population. So there could be something like 4 or 10 or 6. But senators is always the same. Senators is 2. So if we start to make a potential list and we look at this, these are all only going to have one place to go. There's only going to be 2 as the range. So every domain can only go to one range, so this is a function. Every input is only going to one output. Lastly, algebraically, when we're looking at a equation, in order to determine if it's a function, what you really need to do first is you need to solve for y. So we're going to solve for y first, and then after we look at that, we have to determine if every one input is going to give me one output. So if I solve this one for y, I would add the x squared to the other side. And then you want to think, if we plug one thing in for x, how many things are we going to get out for y? So for one input, how many answers are we going to get? Well, if I plugged in 1, I'm only going to get one answer. If I plugged in 1,000, I'm only going to get one answer. If I plugged in -20, I'm only get one answer. So since one input gives one output, this is a function. If you look at the next one, if we solve this one again for y, the first step would be to subtract the x, and then we would have to take the square root. This is where you have to remember, since we're adding the square root to the problem, there's something else we have to add in front of it. You have to put a plus or minus sign in front of it. And now we're going to look at it. If we have one input, how many outputs are we going to get? Well, if I plug one thing in for x, This plus or minus means I'm going to get two things out for y. I'm going to have two outputs. This is not a function. So that's what breaks it. That plus or minus sign is going to break it and make it not a function. Alright, then we're going to talk about function notation. Again, something that shouldn't be anything brand new to you. Function notation is just a different way of writing really the output, which is y. We use f of x. So instead of y in this equation, we're replacing it with f of x. Then we can start to use function notation to plug in, to tell numbers that we want to plug in for the input. So when we see this here, this just means we need to take this and we need to input the 2 in for x, and then we're simplifying. So if you look at the first example here, that's what we're going to do here. This is your input value. We're just going to take that and plug it in for the x's. So it's going to be 2 squared plus 3 times 2 plus 5. You get 4 plus 6 plus 5, 10 plus 5. You're just going to get an output value. That's our output value right now is 15. So they're inputting, by inputting 2, we get an output of 15. In number 2, they're asking us to input that t. So just instead of the x's, those are all going to swap out to be t's. So it's going to be t squared plus 3t plus 5. And that's just your answer. You don't have to try and simplify that at all. You're just trying to figure out what the expression is that would happen if we input t. The last one, we're going to have a little bit more algebra to do. We're going to do x plus 4 squared plus 3 times x plus 4 has to go in for x plus 5. Please make sure when you're plugging in a group like that, you use parentheses. So I just took this and plugged it in. And now we've got to simplify it. This guy right here, you've got to be careful with. X plus 4 squared is a binomial. We're squaring a binomial. I have a phrase I say, you're going to hear me say it a lot. When you square a binomial, you get a trinomial. So you have to do x plus 4 times x plus 4 to get that true answer. It's not just x squared plus 16. We got to work it out. It's going to be x squared plus, there's a middle term, 8x plus 16 plus 3x plus 12 plus 5. I distributed my 3. And then we're just going to combine like terms, and that's all you have to do to finish this guy. So it's x squared plus 11x plus 33. And that's your answer. On this next page, if you pause and try these next 3 on your own, I had the kids in class try them on their own, and then you can watch the video to see how it's solved or if it scored the video, but I would pause and try these next 3 on your own. I'm starting in 3, 2, 1. So number 1, we have to plug in 2. That's going to be 14 minus 2 times 4. Make sure you do the exponent first, which is 14 minus 8. You should have gotten 6. And number 2, they're asking us to input the negative 4. So we're plugging in negative 4 into both the x spots. We get negative 28 minus 2 times 16. We get negative 28 minus 32, which is negative 60. And then the last one, we're plugging in x minus 1. This is the one where you got to be careful with your algebra. It's this part right here, you got to be super careful. We're squaring that binomial. When you square a binomial, you get a, did you say it? Trinomial. So it's going to be 7x minus 7 minus 2 times, this is going to be x squared. The middle term, my shortcut for finding the middle term is I just multiply the 3 parts together. So I'm doing x times negative 1 times 2. You're going to get negative 2x. And then the last one is going to be the negative 1 squared, so you're going to get 1. Or you can FOIL it together. So to finish this, it's going to be 7x minus 7 minus 2x squared plus 4x. Make sure you're distributing that negative 2 minus 2. And then just combine your like terms. You get negative 2x squared plus 11x minus 9. So that's the final answer for that one. The next part of this looks confusing, but it's what's called a piecewise function. A piecewise function is a function that's defined by 2 or more equations over a specified domain. It's something that if you were to look at a graph of a piecewise function, you would end up with something like this one in particular would look like a parabola for up to 0, but then past 0, greater than 0, it's going to look like a line. So they're very separated. All you have to do for these types of problems, piecewise functions are a much bigger thing in calculus, but for these types of problems, you just have to figure out which part the x value falls into. So since I'm looking at -4, I have two options right now. I have x is less than 0 or x is greater than or equal to 0. I need to figure out where -4 falls. -4 is going to fall in the one that says less than 0. So that's the one I'm going to plug into here. I'm going to plug in -4 squared plus 3. That's 16 plus 3 equals 19. You're just looking for the correct output value. There will only be one answer. And then the next one says 0. So then that one has to be where it says equal to 0, which is this bottom one. So that says we're going to plug 0 in as input, but only in the bottom one because that's the only one that has that domain. So we do 0 minus 4, which is -4. And then the last one says +2, which is bigger than 0, so that also goes in that last part of the piecewise function. We'll do 2 minus 4, which is -2. Okay. Now this is the last page for part 1. So for the first day's homework, you just have to go through this page. These ones you just have to pay attention to the directions. They're going to tell you exactly what to do. We want to find all real values of x such that f of x equals 0. So you're going to start by literally doing what they asked you to do. You're going to make f of x 0. And then you just have to solve for x. That's what they want to know right now. So it's going to be -3x. So it's going to be -3x equal to -12. And then you're going to divide by -3. And you just get an answer of x equals 4. Same thing in the next one. We're going to set it equal to 0. And then we have to solve this equation. So this one we will have to factor. I'm going to show my little fancy x thing again. For my x, a times c goes on the top, b goes on the bottom. And the top number is your multiplying number, the bottom number is your adding number. So we're looking for two things that multiply to +6 but add to -5. So that's got to be -2 and -3. So this factors to x minus 2 times x minus 3 equal to 0. We get x equals 2 and 3. So you can have more than one answer for these. The last one, the directions are different. You just have to follow what it says. Find the values of x for which f of x is equal to g of x. So they gave us two functions, but we literally just want to take these two functions and set them equal to each other. So it's just x squared minus 1 equal to -x squared plus x plus 2. And then we've got to use our algebra. We want to get the x squareds together. So I'd add the x squared to the other side. We get 2x squared minus 1 equals x plus 2. And now since there's an x squared in the problem, that kind of takes over, it takes control. Everything should move towards it. So it's going to be 2x squared minus x minus 3 equal to 0. And I'm going to show you one more time my fancy way of factoring. Since there's a number in front, where you could do guess and check, or we can factor this way. I can multiply a and c to get the top number, that's -6. The bottom number is just -1. And I'm looking for two things that multiply to -6, that add to -1. That should be -3 and +2. And the nice thing about the x is my brain will double check it for me without even thinking. That really does multiply to -6 and add to -1. Then here's the trick. We split the middle term into those two values. So the 2x squared is going to stay, but -x is turning into -3x plus 2x minus 3 equals 0. We're creating something that has 4 parts, because when we create something that has 4 parts, we can factor then in groups. I can make 2 groups here. So then this x can come out of this first group. I'd be left with 2x minus 3. Nothing can come out of that next group, but you have to take something out. So even if nothing comes out, you got to take out a 1. That is their greatest common factor. And now these two here match, which means we can take that out. That is now a greatest common factor, and we would be left with x plus 1. Those are your two factors that you get. And then you would solve them. The first one set equal to 0 will give me an answer of x equals 3/2. The second one set equal to 0 will give me an answer of -1. So we got positive 3/2 and -1.